Next, let us explore the multimedia monitoring portion of the IBM System G social media solution. You can activate multimedia monitoring by clicking the View Multimedia button on the home page or Multimedia from the menu bar. When this page loads, you'll notice pre-cached content that has already been analyzed. In this layout, you'll notice several pieces of information. On the left, you'll notice the Twitter handle of the user who posted this content. To the right of it, you'll notice the content itself, in this case, an image of military vehicles. And to the right of it, you'll notice the time at which the tweet was made, as well as the text or body of the tweet, the retweet count, or the number of times that tweet and its content were retweeted, that user's follower count, as well as their location, if available. Beneath that is the analytics and sentiment that has been run on the visual content of the image. Powered by several visual content analytics tools such as Caffe, developed in conjunction with the UC Berkeley lab. Caffe is able to analyze the image and segment it to identify objects within the image itself. In this example, we notice that Caffe and the system has identified these keyword pairs. It appears that Caffe was able to identify the content is related to deadly attack, the presence of horizontal text, demonstrating that it may be from a news outlet, excellent book, annoying reflection, or busy bridge. As you can tell, the accuracy of this is unique in the sense that the system is able to identify with high accuracy the occurrence of 2 to 3 events, giving it roughly a 60% accuracy. Because this content extraction is dependent heavily on the underlying corpus or training system, the keywords returned are only as good as the image content that the system has been trained on. In this example, the system has been trained on public domain images and keyword pairs associated with them. This is why you'll notice the system is particularly good at identifying objects or scenes, such as cars, or what the system detects to be a busy bridge or busy traffic flow. It's important to note that the system is not 100% accurate. However, as we can see from this example, it is quite accurate in identifying several adjective-noun pairs within the scene. Just beneath that, you'll notice the visual sentiment detection, which was done on this image. This visual sentiment analysis is done not only on the image itself, but also using some of the object detection that has been made from the image. For this particular image, the system has determined a negative sentiment. This was an analysis of a cached historic image. Now let me launch the actual live monitoring system and show you tweets as they're coming into the system. Let us select the channel NYC. As the system launches, it is collecting images in real time that are being monitored under our channel NYC. As we allow the system to run, it is collecting the image content of the tweets in our channel NYC and analyzing them to identify both the content and the sentiment of the images included in the tweets. I'll allow this to run for a few seconds so we have some tweets to explore. It is important to note that this multimedia module can be launched on either a channel, which is a predefined group of words, or the co-occurrence of particular words within a tweet, as well as on any underlying tweet search using a keyword such as Apple or iPhone. Now that the tweets have run, let me stop the monitoring and we can analyze some of the tweets that have been collected. Let's take this tweet as an example, tweeted by the user Simon EMBA. In the tweet, it says, sharing the importance of understanding each other, at Matrix Insights, interaction style, at Simon School. This user has 7 followers and appears to be tweeting from the location of New York City. In this image, which appears to be a roundtable session of several students at a university, we can see the system has identified interesting adjective-noun pairs. Notable here are the adjective-noun pairs Great Hall, which is most likely detected because of the presence of a group of people as well as a large aerial space above them. Interesting, the system has also identified the adjective-noun pair crowded street. This is most likely the result of the densely packed population of people which the system has identified. Also along with that crowded street, we see busy street. Here's another unique example. When you're so happy about life, you can't just stop smiling. This was tweeted by the user Robbie R. Rocks. It looks as though the system has identified the adjective-noun pairs handsome smile, as well as adorable smile and chubby face, or stunning smile. It's interesting that the system was able to not only identify the presence of a smile, but also the texture and composition of the face itself. Here we'll note that the visual sentiment detection is indicated as positive. Here's another unique example in the fact that the system has identified the presence of a group of women, which has been correlated to previous images which were tagged as either crazy girls or great night. As we continue to expand the tweet corpus and the image library which are used to help fuel the presence of these adjective-noun pairs, we will be able to refine and improve the accuracy of this auto-tagging feature. Here's an interesting example of an image that is tweeted containing a picture of Justin Bieber. This was tweeted by the user D4NTE in Nueva, New York, or New York. Interesting, the system was able to identify the event of an outdoor concert, as it appears that there's a musical performer performing in a public space. Finally, let's look at the example here by SLY Frank. The image of the musical performer Drake from 2011, tweeted from the location Queens, New York. Interesting, the system has been able to identify and correlate the presence of a famous actor or hot guy, as well as the occurrence of something it's identified as annoying guy. The sentiment of this image has been identified as positive. This research that fueled this analytics and visual engine is still being refined. So as you can see, the accuracy is not 100%. However, this multimedia module gives us a very clear example that a system highly trained and using a very large library of known images and or adjective-noun pairs can be used to identify the presence of particular objects, sentiment, or visualizations within multimedia content. We are very excited to explore and refine this process going forward, and are confident that using these tools we can help identify particular objects with greater accuracy, as well as extrapolate from the presence of particular objects in relation to other objects the sentiment and or actions related amongst them.